Yeah, Santiago. Settle a little tiff that Kevin and I are having.
Let's be honest, Raymond, it's not a tiff, it's a row.
And now it's a scene.
It's okay, sir. We don't want to get involved in your personal life.
It's not personal, it's a math problem.
Pass.
Raymond and I had dinner together last night for the first time in 2 weeks, thanks to the night shift.
And Kevin thought it would be fun to spoil our date with an inane math problem, to which his answer is wrong.
Enough foreplay. Let's get to the numbers.
It's the Monty Hall problem. Imagine you're on a game show. There are 3 doors, behind one of which is a car.
You're telling it wrong. There are 3 doors, behind one of which is a car. You pick a door. The host, who knows where the car is, opens a different door, showing you there's nothing behind it. Now the host asks if you'd like to choose the other unopened door. Should you do it?
No.
Yes.
So the big question here is, does switching the doors improve your chance of winning the car or not? Okay, let's jump into the solution. First, let's see our beloved Captain Holt's perspective. So initially, when you don't know the answer, you can choose any of the 3 gates. So the probability of winning the car is 1 by 3. Okay, so initially when you don't know anything, the probability was 1 by 3, 1 by 3, 1 by 3, as car can be behind any of the 3 doors. Okay, now when the host opens gate number 3, that is this, now you know that the car cannot be behind gate number 3. So the probability of winning a car in gate number 3 becomes 0. And for gate number 1 and gate number 2, randomly it becomes 1 by 2 and 1 by 2. So mathematically speaking, there is no point of switching. Okay. But what Captain Holt is missing is key assumption of the problem, and that is the host must always open the door that was not selected by the contestant. The second assumption is the host must always open a door to reveal a goat and never the car. The third key assumption is basically the host must always offer the chance to switch between the original answer and the remaining closed doors. Okay. By following these assumptions, let's take Kevin's perspective. Okay. So initially when let's say you have chosen door number 1. So the probability of door number 1 was basically 1 by 3. Okay. And the combined probability of door number 2 and door number 3 was 2 by 3. Okay. So now when the host reveals that the goat is behind door number 3, that is here, now the car can be behind door number 1 or door number 2, and it can be behind door number 3. Okay, so the probability of door number 3 becomes 0, and this whole probability of 2 by 3 now shifts to door number 2. Okay, so here in this scenario, the probability of winning a car in door number 1 is basically 1 by 3, and the probability of winning the car in door number 2 is now turns to be 2 by 3. So if you switch, your chance of winning jumps to 2 by 3. There is another method of solving this problem, and this seems to be more mathematical solution rather than an intuitive solution. Let's see, if your teacher asks you for 5-mark answer rather than 1-mark answer, how can you solve this problem? Okay, so now I have shown you these 3 scenarios, scenario 1, 2, 3. And let's say, suppose you have chosen, in scenario 1, you have chosen door 1 and the car is behind that. Okay, so before the host opens any of the gate, the probability of randomly choosing any of the doors is basically 1 by 3. Okay, and now if you have opened door number 1 and the host knows where the car is, he can open any of the door, that is door number 2 or door number 3. So he has chance of opening any of the doors. So the total probability of winning here in this scenario becomes 1 by 6. Okay, now let's come to the second scenario. So this is scenario 1. Let's come to the second scenario. Suppose you have chosen gate number 1 or door number 1, but the host knows that car is behind door number 2. So he will not open door number 2 here. Okay, he will only open door number 3. So in this scenario, randomly opening any of the door, the probability becomes 1 by 3 into 1, because host will only open door number 3 and not door number 2. Okay, so in this scenario, the probability becomes 1 by 3. At the end, when you have chose door number 1 and car is behind door number 3, so host will not open door number 3 at all. So in this scenario, the probability becomes 0. Okay, now you can directly see here that the probability in first scenario is basically 1 by 6, and probability in second scenario is basically 1 by 3. That is twice that of scenario 1. Okay, so if you switch, you have twice the chance of winning the car in scenario number 2 rather than if you don't switch. Thank you everyone. If you like this video, please do subscribe to my channel, and this is my first YouTube video, so I would appreciate any of the feedbacks. Thank you so much.